Well, thank you. And thank you, Subterranea Britannica, for inviting me this evening. So, underground warfare in the First World War is my topic for tonight, a subject that's been very deep interest of mine for more than 30 years. And here's what we're going to cover this evening. What mining was, who was doing it, the miners and the mining engineers, what expertise and technology they brought to military mining during the First World War, the tactics that they used, and a quick evaluation of military effectiveness. Was it any good? And for this talk, I'm going to especially focus on numbers 2 and 3, the miners and the mining engineers, and the specific technology that they used and the methods that they used, because I think that'll be of most interest to sub-Brit members. So first of all, what was military mining? What do we mean by that? Well, it's an activity, a means of warfare really as old as fortifications. And by 1914, it had really drifted into obsolescence, and especially in the later 19th century, it seemed that this activity that had been going on for centuries was really not going to be needed anymore. The advances in artillery meant that the sort of very sophisticated attack you can see in the drawing, a mining attack during the Crimean War, French mines on the left coming in to attack the Russian fortress at Sebastopol. There was a brief resurgence, a little bit of resurgence at the beginning of the 20th century in military mining as a result of the Russo-Japanese War, when in fact a siege at Port Arthur played a major part in the fighting, and also trench warfare, linear continuous lines of trenches facing each other at Mukden, which it seemed could only be broken by mining. So most European countries, including Britain, did begin to practice mining again. So the photograph you can see of mines being blown at Chatham in 1907 during siege exercises. But that was only one part of underground warfare during the First World War. With trench warfare, there we are. With the onset of trench warfare, it really split into 3 general areas of activity. So military mining, the traditional means of besieging a fortress, was adopted for trench warfare. You can see in this simple drawing, military mining in the early months of the war, following the 19th century practice, shallow tunnels, maybe 20 feet, 30 feet below ground, being burrowed in an attempt to get beneath the enemy lines. But also with trench warfare that really spread along the Western Front during September and October 1914, moving underground became the key means of protecting troops from artillery fire. And so the second aspect of underground warfare was dugouts. And we can see here a typical 1915 dugout, maybe 5 or 6 meters below ground, enough to protect troops against most shell fire. And this became a major part of trench warfare, a major means of survival for troops in the trenches. But the third aspect of underground warfare was the use of tunnels to attack, and especially as a means of overcoming the deadlock of trench warfare. And we can see in this plan, German trenches on the right. This happens to be a plan of British use of what were called Russian saps during the Battle of the Somme. Shallow tunnels, maybe 20 foot below ground, being pushed beneath no man's land in an attempt to get across no man's land, not to undermine the German trenches and blow them up, but to feed supplies across once the front line was captured. And I'll talk a bit about that towards the end of the talk. So tonight, I'm really going to focus on military mining. And although, as I said, this is becoming somewhat obsolescent by 1914, what's going to happen is that it will reach really a crescendo of intensity during the First World War, really the last hurrah of military mining is during 1914 to 18. And it starts almost immediately with trench warfare. As soon as the Germans dig in along the line of the River Ain in September 1914, and these trench lines spread north and south from the North Sea to the Swiss border. As soon as you have the beginning of deadlock, then both sides begin mining. By both sides, I'm talking about the French and the Germans here. The British have a very small presence in the early months of the war, of course. And that mining is carried out very much according to the existing 19th century military manuals. Shallow tunnels, 15 to 30 feet below ground. Small galleries, as you can see in the photo of a French mining gallery in 1915. Close timbered. The military mining manuals advocate pretty much you always close timber your galleries regardless of the ground that you're digging through, because it will protect your galleries against underground explosions. And also soldier miners can't be expected to be able to read the ground as well as experienced miners. And a feature of military mining in the early months of the war into 1915 was that the Germans were better at it. Germans were better at it because they had more personnel, they had more engineers available, they could bring them out of the fortresses on their frontier. So they were not only trained and equipped for mining, but there were spare troops that could then be added into the line and make up for the shortage of engineers that inevitably occurred with trench warfare. So these German engineers, you can see in the larger photograph, evidence that they are some at least are miners, because we have the miners' motto Glück auf that they've put above their mine entrance. And they have larger tools, they have large size tools, as opposed to the rather small miners' tools that the military favoured for these little galleries. You can see the French miner on the left has got rather a small pick, whereas these Germans have got bigger tools. However, indication that they are still following the military practice is that little spoil wagon that they've got, little spoil truck, which indicates the very small dimensions of the galleries that they're digging. So small galleries, shallow, close timbered was the pre-war method. And these galleries, these techniques would have been entirely familiar to the engineers of the Crimean War, the Napoleonic era. And for the Germans, they tended to talk about this mining as being like the mining of Frederick the Great. And another feature was that they were still, in the early months, still using gunpowder, still using black powder. So black powder used since the 1300s for warfare purposes and mining purposes. Charges of about £1,000 or about 500 kilograms. And this was a big problem for the British. So the British are holding a smaller section of front in Flanders, and they basically ran out of engineers. They didn't have enough engineers to maintain trench warfare and also cope with active mining. In December 1915, the Germans were able to carry out a mining attack against the British Indian Corps and in effect blow up and capture quite a length of front line from the Indian Corps. This led British commanders to ask the War Office for a battalion of miners or navvies to counter this. And a mining engineer, contractor, Sir John Norton Griffiths, heard about this. He happened to be a friend of Kitchener. He managed to arrange a meeting with Kitchener, and according to Norton Griffiths, he demonstrated to Kitchener a method that his navvies, his tunnel navvies, were using to dig through the clay for sewerage in Manchester. They were digging sewers in Manchester. They're using a method called clay kicking that I'll show you a picture of in a moment. And Norton Griffiths claimed later that he demonstrated what clay kicking meant by taking this little shovel from the fireplace of Kitchener's office in the War Office, lay on his back and demonstrated it. And Kitchener was very impressed. He said, "Get me 1,000 of these men." Griffiths had to say, "Well, I've got about a dozen of them working for me at the moment." But in February 1915, 17 of these clay kickers were signed up as sappers in the Royal Engineers, and within 48 hours, they were taken from digging sewers in Manchester to digging tunnels in Flanders. And that was the beginning of a series of British units called tunnelling companies, comprising the small number of clay kickers they were, predominantly also coal miners, with mining engineers as their officers. And these units, very much at the urging of John Norton Griffiths, who was made a mining advisor to the BEF, British Expeditionary Force, in 1915, he really pushed for the proper civilian expertise and technology to be employed in this growing, burgeoning mining war. And at Norton Griffiths' urging, the officers for these new units, these tunnelling companies, were mining engineers. So a regular Royal Engineer officer would be placed in command, but all the other officers would be qualified mining engineers. So appeals were sent to Royal School of Mines, for example, Camborne School of Mines, for suitably qualified men to apply. They were given temporary commissions, and typically within 2 weeks were sent to France. And these men brought with them obviously a huge amount of experience, but also the latest technology. Typically there would be a kind of distinction amongst them between those who had come from the collieries in Britain and those who, in their own view, were more adventurous and had gone abroad, gone to the Empire, and were working in mineral mines around the world, British Columbia, South America, Siberia, Malaya, anywhere you can think of, really. And they gave up often very well-paid jobs, came back to the UK, and were sent to these tunnelling companies. By the end of 1915, at Norton Griffiths' urging, we have the first of these temporarily commissioned mining engineers actually being put in command of the tunnelling companies, which is a kind of major step for the War Office, quite a bold step, because they're worried, initially at least, about the discipline of these units, not only the officers, but in particular the men. So two of the key early commanders, just to give you a couple of examples, William Clay Hepburn, a Monmouthshire colliery manager, who was already in the Territorial Army, commanded one of these tunnelling companies, 172 Tunnelling Company. He pioneered the driving of shafts through the wet sands of Flanders to reach the dry clay below. Did that during 1915, and he was the first non-regular to be appointed. In the British Army, the territorials played a key role in bridging the gap, if you like, between the regulars and civilian experts. Likewise, the system of special reserve officers meant that there were civilian experts who were already within the armed forces. The other man, Cecil Howe Cropper, a New South Wales mining engineer, commissioned into the British Royal Engineers. He also commanded one of these companies at the end of 1915 and conceived the Messines Ridge attack, which we'll see more about later on. So the rank and file, equally very important. So there weren't many of these clay kickers around, but there was a very large number of coal miners available in Britain. So I think it's about 1 million men working underground in coal mines in 1914. So there were lots of men. There were, in particular, a lot of older miners, these miners in their later 30s, 40s, 50s even, who had tried to enlist in 1914 and either been rejected outright because of their age or because of their injuries, because being miners, they would inevitably have bits of their bodies broken or missing, and had then been rejected and were given another chance to join up. So large numbers of miners were directly enlisted and with minimal training. Typically about 8 days after signing up, they'd be sent to France, were put into these tunnelling companies. And about half of the strength were created from these direct enlistments. The other half of the personnel for these tunnelling companies were found actually in France in units, mostly infantry units that were already serving. And appeals were made for volunteers on the strength of getting some extra money, getting engineer pay, to transfer to the tunnellers. So they did get men with experience of the front line to compensate for the miners who were coming with no experience at all. So they're getting 2 shillings and twopence. Pay was obviously quite important for miners who were well paid. They had the option of paying a certain proportion, 6 shillings a day. It became an incredibly complex problem for the tunnelling companies, in that Norton Griffiths rashly just promised men 6 shillings a day to try to compete with what they can get in civilian life, whereas when they got to France, they were to discover that only a small proportion were going to get the 6 shillings. It was a problem that dogged the tunnellers for much of the war. So there was a worry at first, I think, amongst in the War Office about the idea of just enlisting en masse these untrained miners. There'd been bitter industrial disputes before the First World War with miners. They have this reputation for militancy. But these tunnelling companies actually turned out to be amongst the most successful in the British Army during the First World War. And I think the reasons for that, obviously they had proven skill. They were very good miners, and they had to have a certificate from the colliery manager to attest to their experience as miners. But they also have a whole series of qualities that armies work very hard to instill in their men. So they have strength and stamina. They're used to danger. They're used to being underground, so they have a sense of a pit sense as to how to stay alive underground. But also they're used to trusting their lives with the man who's working next to them, just as soldiers will come to trust their lives with their mates. So they have a lot of the qualities which armies try very hard to instill into their soldiers anyway. And I think that's one of the reasons why they were so successful, even though they never quite got military discipline. So maybe the exemplar of these qualities, the one Victoria Cross awarded to a tunneler for bravery underground was a posthumous one for William Hackett. He was one of these older miners who was enlisted directly from the collieries. And in June 1916, he lost his life when he refused to leave a man trapped underground. And over a long period of time, over several days, he was repeatedly ordered to leave the gallery underground where another man was trapped and refused to do so. The citation says he refused to do so with the words, "I'm a tunneler, I must look after the others first." Other versions say, "I must look after my mate," which sounds maybe more believable. So Thomas Collins was trapped underground, and their bodies were lost underground eventually when Hackett refused to leave him. So by mid-1916, tunnelling really reaches its peak on the Western Front. And on the British side, 25,000 men are working underground. So they're in 33 British tunnelling companies on the Western Front, made up of 25 British, 4 Australian, 3 Canadian, and 1 New Zealand. And the Germans have the same number of personnel engaged opposite the British. And equally, on the mining hotspots on the French front as well, you have equivalent numbers of men engaged in this activity. So June 1916 really sees this activity reach its peak when the British tunnelling companies are really pitching this underground battle for ascendancy with the Germans. And that month alone on the British front, 101 mines were blown, underground explosions, and 126 German. And the aerial photograph shows you the craters running along no man's land, give you an idea of the physical scars. However, the majority of those explosions will not have broken surface. Those are purely explosive charges being detonated in an attempt to stop and destroy enemy mine galleries crossing no man's land, trying to get under their opponent's trenches. So purely to maintain the status quo. So the expertise and technology which these men brought to underground warfare. So special techniques that were unknown in the Royal Engineers, didn't feature in the military mining manual. Clay kicking, this is what it looked like. Working on the cross, as it was known, it was a way of digging a very low tunnel through clay, and it's not easy to use a pickaxe to get through clay, but if you lay on your back and use a modified spade called a grafting tool, you can use the strength of your lower body to cut out chunks or spits of clay and lever them out. And this was a very effective method for digging these low galleries through clay. So this is what the Norton Griffiths clay kickers, his tunnel navvies, were skilled at doing. And this was a skill that was learnt by miners as and when they needed it. So clay kicking was something they brought with them. Another example of working through difficult ground, spiling, as they called it, sheet piling, especially needed for working through the wet sands of Flanders. Before you reach the clay, you have to work through a lot of wet sand. So whether you're digging a kind of lateral horizontal tunnel, or whether you're digging a shaft, you can use spiling by gradually feeding in these piles to support the wet, sandy soil. And they brought with them non-standard tools. So on the left, you can see the various grafting tools used for clay kicking, and every tunnelling company had its own favoured design, which they obviously all thought was superior. I mentioned about traditional military mining tools being kind of small versions of large tools. I think these are rather despised by the professional miners. Their demand for working through hard ground, like hard chalk, was the hardy pick. You can see in the middle, that's one that we recovered on the Somme explorations at La Boisselle. Big demand for hardy picks with the reinforced collar, just to get through the hard chalk that you'd encounter at sort of 40, 50, 100 foot depth. but also the push picks that they would use. And for silent work through chalk, you'd have to use a bayonet attached to a haft to try to kind of quietly lever out the chalk. So whatever your strata, whatever you're digging through, you'd have different tools, and all of these different tunneling companies, 33 different tunneling companies, all favoured different tools. There was no attempt by the army to impose consistency, and they're happy to allow everyone to do their own thing. And all GHQ did in this respect was just spread information about what everyone else was doing. So tunneling company commanders were allowed to use whatever methods they felt was most effective. So we saw that little mining truck that the Germans were using, typical of 19th century practice. So the professional mining engineers have got different ideas about haulage. Obviously, in mines and quarries, haulage was a major something of major importance. The galleries are increased in size, but they're still quite small. And haulage tends to be with larger sized trucks on the British side. These are 12-inch gauge, still quite small. Run on wooden rails and with rubber tires for silence. So this was something that they'd never encountered in civilian life, the idea that you have to work quietly so as not to alert your opponent to your activity. So haulage, mostly done by hand, but there was also mechanization, which is introduced. So powered haulage was used to increase the removal of the spoil. And of course, these trucks would then be used to take explosives up to the front line for preparing mine charges. Another important area of expertise, very important indeed, is the introduction of professional geologists. Now, the mining engineers themselves are trained in geology, but also really expert people play an important part. So William King, WBR King, you can see in the centre, also very important in the Second World War. And Sir Edgeworth David, so maybe, I guess, the most famous geologist of his day, member of Shackleton's expeditions, comes over with an Australian mining corps in 1916 to the Western Front. And they have major contributions, not just to aspects of underground warfare and military mining, but in particular water supply as well. And their contribution is, from our point of view, is in identifying the places where dugouts can be dug in Flanders. So some places it's so wet that it's really not worth trying. And also the seasonal fluctuation of water level in chalk, and this is something that Edgeworth David established, because in the spring the percolation of water through chalk will mean that the water level actually rises, so that if you dig an extensive mine system beneath no man's land, for example, at 80 foot below ground, if the water level rises 5 or 10 feet in the spring with the winter rains percolating through, your entire defensive mine system could be completely flooded. And within a few weeks, you could be rendered completely defenseless. So he established what that fluctuation was, which was a very valuable piece of work. But in particular, the clay level used for the Messines mines attack was established by the geologists. The other guy, Professor Barrois, was the professor of geology at the University of Lille in German occupation for most of the war. So this clay level at Messines. So from the point of view of military mining, the most important knowledge, really professional knowledge, that the civilian specialists brought to underground warfare. So the geological profile that you can see at the top of the page, I've sort of married up with the plan for the Messines mines by turning it on its side. So the top profile is showing you really the shading between wet sands that overlie Ypesian clay. So the blue band at the very bottom of the profile is the what you might know as London blue clay. Here it's Flanders blue clay. It literally is blue when it's exposed to the air, as it were. Turns quite a distinct colour of blue. And the mining engineers realised, and especially Hepburn and Cropper, those two that we saw earlier, realised that if they could sink shafts through the sands which overlay the clay, then they could dig far more successfully through that clay. And they identified that before you reach the blue clay, you have kind of an intermediate sandy clay that was actually perfectly good for putting a tunnel through. So if you can sink a shaft between 50 and 80 feet or 100 feet below ground into the clay, then you really can launch a comparatively simple mining attack on the Germans. And because the British held the low ground and the Germans had the high ground, that meant that the British were actually closer to those clay levels. So you're looking at the Messines Ridge held by the Germans. Typically, of course, the Germans always hold the high ground. And because we were lower, we were closer to those clay levels. So it's Panisalian clay that is, in fact, the intermediate mix of sand and clay. And the little black squares are the depths of the mine charges, some of the mine charges of Messines Ridge, and they're mostly in the intermediate Panisalian clay. So the plan below is the trench map with the German lines in red and the British in black. And you can see the mine galleries beginning behind the British lines and extending underneath the German positions. So I've turned this around, so north is on the left of the trench map, if that's clear. I was rather pleased to be able to match up the underground profile with the mine plan, but it may not be entirely clear to you looking at it now. So by using and understanding the geology, the British were able to carry out this very successful attack in which ultimately 19 mines were placed beneath German positions and then detonated simultaneously in June 1917. So here's more detail of how these levels were penetrated. Now, the Germans never quite got this right. And the Germans are being overtaken during 1916 by the large numbers of professional mining engineers that the British are able to introduce into their units. And the Germans find it difficult to get through these wet sand layers. So this is a German diagram at the top, both German diagrams. A German one at the top showing how they tried to sink concrete lined shafts through the wet sand to the clay level. And obviously, the reason why it's so wet in Flanders, why the water level is so high, is that you have these beds of clay that prevent the water from draining through. If you can get down to the clay, then you can dig more effectively through it and it remains dry. And the lower profile shows the problems that you'd encounter if you did get through to the clay level, the ton, in that the irregular depth of the clay and the sand meant that you can accidentally run into that sand. And where that occurred, the sand was under such pressure that within hours, a mine gallery could be completely filled with wet sand and would take a long time to dig around. So you have to stay in the clay level. So you really need to know where the clay is. So as I said, the Germans try to use concrete. And here, the photograph shows German mine shaft They're attempting to get down. They haven't got down very far. They don't look particularly happy about it. They're trying just to use this hand pump to dewater it. And the Germans believed that it was impossible to get shafts down through the sand, the wet sand. The response from the British mining engineers was to use steel tubbing that they would force down using jacks. So typically there might be 4 jacks, 5-ton jacks turned upside down, and to use to force down these cylinders. And there's a sort of sharp cutting edge at the bottom, and then you'd be pumping out, digging out the sandy slurry from the middle of the tubbing. And some of these shafts took up to a year to get down the 100-foot or so depth down to the clay. And these shafts, I think, that the British sank for the Messines attack are amongst the major engineering achievements of the Western Front. For the mining engineers, it was maybe not second nature, given the conditions that they had to do this in terms of the proximity to the enemy, the danger of it. But sinking a shaft through difficult ground is something that they would have been trained for, something they would have been doing in their professional lives. So they knew the equipment and they knew how to do it. It's interesting when we look, however, at the German response, the German attempts to solve the same problem. Germans are quite fixated with concrete. They do amazing work with reinforced concrete on the Western Front during the First World War. And they try to just use concrete to solve this problem. So they try a method of using blocks to line the shafts through the wet sand. And you can see one surviving, one of these mine shafts surviving. And that's not very successful. And then instead of just using the tubbing, they have a kind of combined steel shuttering system. And you can see the this shuttering, this tubbing under construction. There's the cutting edge in the photograph at the top that will have to be forced down. And there are two sort of skins of steel that would then be filled with reinforced concrete, which you can see in the lower photograph, a shaft that they're trying to sink on the Messines front. And I don't know why they did this rather complex system, why they use this rather complex system of a combined sort of steel tubbing concrete reinforcement method. And they didn't have a lot of success in getting down to the clay levels to counter the British mining attack. So other methods of mechanization are also being used. And although I'm showing you British examples, British and Dominion examples, both the Germans and the French have highly effective engineers working on their sides, bringing in new technology. But in particular, mechanization is used for the actual physical digging and boring of tunnels. So various types of hand boring machines were used, as well as drills, electric and pneumatic powered drills. The wombat borer was a particularly successful one. You can guess maybe that it's an Australian invention. Lieutenant Hunter, Stanley Hunter of the Victorian State Mines Department, came over with the same Australian Mining Corps expedition in 1916 to the Western Front, and he brought his wombat borer, and that was used a lot for various boring requirements. Other types of tunnelling machine were tried. Norton Griffith's really last swan song, as he hoped it would be on the Western Front, was to bring over a tunnel boring machine, the Stanley heading machine, which dug a 6-foot diameter gallery and that was lowered down shafts to a 100-foot tunnel on the Messines sector. Was not successful because the clay, as it was exposed to the atmosphere, just swelled as it absorbed moisture and tended to grip the machine fast as soon as it was stopped cutting. So that was abandoned 100 foot below ground. Other tunnel boring machines were also tried, both by the British. A Whittaker machine was tried, of the type that was also used to try and cross the channel, dig a channel tunnel in the 20s. The Germans tried an electric tunneling machine at Hill 60, and that was also unsuccessful as well. So it was, in terms of digging the tunnel, it was always manpower. It was always back to the men. Explosives, also, mining engineers knew much better explosives than those that were in use by the military. The standard mining explosive in 1914 was still black powder, the same gunpowder that had been used for centuries. And in the later 19th century, high explosives had been developed. The British mining engineers favoured an explosive called aminol, ammonium nitrate based explosive. You can see a mine charge on the right that was found at Vimy Ridge in 1989, 6,000 pound, 2.7 ton charge of aminol. But the Germans also very quickly, and the French very quickly, introduced their own commercial blasting explosives, peridite, dolerite, for example, from the mining and quarrying industries. And these increased the power of mines, the size of mines. So whereas at the beginning of the war, you had mine charges of maybe half a ton, very soon, by the end of 1915, you have very large charges, 3, 4, 5 tons, 15 tons, getting larger and larger. So by the time of the Battle of Messines, the British lay a charge of about 43.5 tons, Saint-Eloi, the largest British charge. The Germans had already laid a charge of 50 tons, Vauquois, in 1916. And the detonation of explosives underground meant that a whole other area of expertise had to be called on from the mining industry. So when you detonate explosives underground, especially if it's a camouflage, that is an explosive charge that doesn't form a crater on the surface, then there's nowhere for the explosive gas to vent. So you've got huge quantities of, in particular, carbon monoxide and also methane, which are trapped underground. And the carbon monoxide became, in fact, the biggest killer for the tunnelers working underground. This is a cartoon illustrating a real incident that one of the miners in 172nd Tunnelling Company, F.J. Mulqueen, recorded in his memoirs. And that's Mulqueen there. And he's arriving at the front, at the face of the tunnel. The Germans have recently blown a charge underground, and you can see the damage to the timbers. And you can also see a cage in the front with a dead canary in it. And the mining officer is saying, "What the devil are you men doing here when the canary's dead?" And the sappers replying, "That bird never had any guts, sir." So the miners are carrying on working, even though the carbon monoxide has killed the canary. So they're making light of a very considerable, frightening hazard. As you all know, carbon monoxide, no smell, you can't see it. The first symptom you may have from high concentrations is simply to collapse from it. All miners would get headaches from working in concentrations of carbon monoxide. So mines had to be ventilated, and again, mine ventilation is something that all miners and mining engineers understood, and something that had been was dealt with in the commercial world. These galleries are still on a smaller scale to commercial mines and collieries, and the solution was often to use large bellows. They're called blacksmith bellows, but they're of the type designed for blacksmiths, bought and shipped over. This is the photograph is of the exploration that we did at La Boisselle, where we discovered the chamber where the blacksmith's bellow had been situated, covered underground chamber originally, and you can see the triangular shape where the bellows would have been, and the recess at the front where the operator would have sat, and there was a little shape carved out of the chalk for the man who would have been sitting pulling on a lever, and the drawing of the bellows are the type that would have been used. So those would have ventilated a gallery maybe 500 up to about 500 plus feet long to a reasonable degree. There was mechanized ventilation as well, although British didn't like the mechanized ventilation so much because it was noisy. You could hear it, they could always hear German ventilators going. But another aspect to it, and especially in relation to the carbon monoxide and the methane, gas safety meant that it was realized that you actually had to prevent this gas flooding through the galleries. So at La Boisselle, we found this example. We had several examples of the very heavy gas-proof doors that the British installed in the galleries. And these had to be strong enough to withstand the blast wave of underground explosions, because they had to prevent the carbon monoxide from flooding through the galleries. It had to isolate it as sort of bulkhead doors to stop the gas from filling the galleries if there was an explosion underground. In these galleries, the British actually lost 18 men in one incident when there was a secondary detonation of methane that had been released by an explosion, which then sucked in the vacuum created by the secondary detonation of methane, sucked in a huge quantity of carbon monoxide, killing 20 men, including the company commander. And also, rescue squads had to be trained and equipped. So in the event of an explosion underground, men would often be injured by carbon monoxide, often be affected by carbon monoxide that had to be rescued. And so every company had its own rescue squad who were trained and equipped with the latest self-contained breathing apparatus. So the proto apparatus that most of these men are wearing, made by C.B. Gorman, was bought on a large scale by the War Office to equip tunnelling companies. And every officer went through a training course in the UK. This is at the Dudley Mine Rescue School. You can see the civilian instructors there who were training them. These are obviously civilian mine rescue specialists. And schools were also established on the Western Front, 4 or 5 schools for mine rescue that were continually training both officers and men who were in the proto squads, as they were known, who were using the rescue apparatus. And in fact, the sort of manual of best practice for mine rescue was written by one of the instructors for a Western Front mine rescue school in 1919. So as well as the proto sets, they've also got the oxygen reviving set on the left, and the front right is the canary cage. You can see there's also some gas sampling bulbs there as well, and electric safety lamps. So every mine system had its rescue station within the system. So this might be about 50, 80 foot below ground, specially equipped with the proto sets. You can see the proto man there with his little canary cage. Mice were also used. Canaries tended to give the most obvious sign by falling off their perch, provided you clipped the claws of the canary, so they'd fall off their perch if they were gassed, and they could be brought back to life if you bring them into fresh air. So these squads were on permanent standby in case of explosion. So I've talked mostly about the British units and how the Germans had a head start at first, but were overtaken by the British by the use of these specialized tunneling companies and by the mass sort of wholesale channeling of the civilian expertise and incorporation of it into the British underground warfare. And the Germans first became alarmed about this in March 1916, when the British carried out a successful underground attack, actually on the Messines front, by laying mines in this clay level. And the response to that was to try to imitate the British tunneling companies by creating dedicated German mining companies. Didn't stop the ability of the British to place their explosive charges underneath the German trenches, however. And after the success that the British had at the Battle of Messines in June 1917, the German commander of miners on that front, who was this chap, Colonel Otto Füsslein, wrote an explanation, really, or an account of what had happened and the reasons why his miners had not been able to stop the British tunnellers from getting beneath the German trenches. And it's instructive, the reasons that he gives. And the key ones, he says that many of his miners were being withdrawn to Germany, needed, of course, for the industrial effort at home. And he said also he was denied the equipment that he believed the British had, the effective pumps, the machinery. Also, he refers to the tubbing. He says that they weren't allowed to have this because of, in his words, parsimony and narrow-mindedness. And also, although he had these specialist German pioneer mining companies, he didn't have the same number of mining engineers. And he points to the fact that the German head of pioneers was not willing to allow civilian mining engineers to be placed in charge of the military pioneer units. They had to be field pioneers. So the German pioneer units were seen as being all-round field engineers. He wouldn't allow them to be channeled into being these specialist units. But also there's an issue of sort of command and control of tunnelling, and the British had placed control of their tunnelling companies at a higher level of command, the army level, which meant that they were freed up to really focus on the offensive operations. And Füsslein had all sorts of problems because he was answerable to more lower level commanders, divisional commanders, who had rather short-sighted defensive attitudes. And specifically, he says that they wouldn't let him go deep with his galleries. They insisted on shallow defensive workings. And also there's a military aspect, defense in depth, which I'll explain a little more in a moment. But basically, there was a change in the ideas of defense in trench warfare during the war, in which you don't defend your front line solely, you have a little more flexibility. And Füsslein says that the Germans really didn't get that. The German commanders on the Messines front didn't get that. So he has a whole list of complaints, and a lot of it is to do with the way that the British channeled the civilian expertise into their tunnelling companies. This chap in the middle, in the cap, Kurt Schmeling, commander of one of the specialised mining engineers. As far as I can tell, he wasn't a mining engineer. He was an engineer, but not a mining engineer, civil engineer. Later lost his life during the Third Battle of Ypres. So, a little bit about underground tactics. So I've really covered the way that the civilians were brought in. And the last bit of the talk, I'll just quickly run through the way it was actually put into operation. And this is more of the military history side rather than the mining technology side. So a mine system, as it developed, in the early stages of the war, August 1915. In green, I've plotted a German mine system which is running right across no man's land. So at the top of the photograph, you can see German front line. Then you have no man's land with all the tunnels beneath it, and then running across the lower middle part from sort of lower left up to middle right is the French front line. And German tunnels in green, French tunnels in light blue and pink. And the Germans have a almost complete system running right across no man's land, completely defending it underground against any tunnels that might try and get under their own trenches. And some of their tunnels are getting right under the French front line. The French, however, have a very fragmented tunnel system. They haven't got continuous cover. They've got these isolated galleries. And the French have been unable, really through lack of manpower, to create the sort of continuous defense that you can see on the right of this diagram, where you have your main lateral tunnel underneath and in front of the front line, creating an equivalent front line but underground. And so that 1915 tunnel system, the Germans have that tunnel at about 30 foot below ground. And from that tunnel, you can run out your line of fighting points for both listening, but also detonating charges if you hear the enemy approaching. By contrast, the French, what you can see on the left, the kind of inverted Christmas tree, where you have one shaft, one gallery running out, and you try to use that one gallery for all of your defensive and offensive purposes. And the problem is that the more you detonate a charge, the more charges you detonate, the more you destroy your own tunnels. And if you're not careful, you end up even destroying your own shaft. And that was the situation that the British found at many of the sectors that they took over from the French, including La Boisselle. So just to show you what those look like in practice, the different depths of galleries as they're developed. On the left, you have the old-fashioned 19th century sort of style galleries that were being dug in the early months of the war that the British found when they took over French mining positions. And you can see the dimensions of the timbers, less than a meter wide, about a meter high, and maybe 80 centimeters wide. And the British miners favored larger galleries, still ones that you'd have to stoop in, but much easier to work in, much easier to swing a pick in and to work effectively in. So on the left, you have a gallery that was dug at 30 foot, and on the right, at 80 foot. And it's the 80-foot galleries that were being developed towards the end of 1915 by the professional mining engineers and the tunneling companies. So British take over this system at La Boisselle, August 1915. Within a year, they have developed and created a deep defense system so that they can have a complete underground defense. You can see the dark blue galleries running laterally across the front. And then more faintly, there's brown galleries. So the dark blue galleries are at 80 foot below ground, brown galleries at 100 foot below ground. The Germans, you can see in green, have also massively developed their tunnel system. So their 30-foot transversal lateral galleries, defensive galleries, are augmented by another one at 50 foot below ground, with galleries sinking down to well over 100 foot below ground. So in a year, you have this massively complex mine system, which is invisible, obviously, above ground, and a huge amount of labor has been poured into these mining sectors. And there are dozens of these mining sectors along the front lines in the British and German sectors, sucking in huge amounts of labor just to keep the status quo. Example of the mine warfare at La Boisselle then. So the light blue tunnels, the ones that the British took over, going down to about 30 foot below ground. The dark green tunnel on the left shows how the Germans approached those. They were able to get their galleries right down to, say, 90 foot below ground, and the red gallery is the British response to that. And ultimately, this is how the mine system at La Boisselle ended up. So this is the same sector, just pulled back a bit. You can still see the German galleries in green, British ones in blue and brown, German trenches in red, British trenches in light blue. And the Germans held the village of La Boisselle, and the British were unable to get mine charges beneath the German positions of the village of La Boisselle. And when the British want to use their tunnellers to actually support offensive operations, rather than just keep the status quo, keep the Germans at bay, they faced this problem that the Germans had such extensive underground defences that you couldn't put your mines under the places where you really wanted to. So this village, fortified village of La Boisselle, had to be attacked really from the flanks. And this is what you can see here. So on the left, there's a dark blue tunnel running out and then turning at right angles back towards the Germans. That was a flanking attack placed with a 1,000-foot long tunnel to get under a position called Boisselle. And then on the right-hand side, there is a pink gallery going to beneath where now you have the mine crater, the Lochnagar mine crater. So again, a long gallery placed on the flank, bypassing the extensive underground defence systems. Now, the British managed to reasonably successfully place those mines and blow them at zero for the attack, but they really didn't benefit the attack at all, because the British couldn't get their mines beneath the key tactical German positions because of the existing underground defences. So these mines, placed with huge effort, skill and bravery by the tunnellers, didn't help the attack at all, sadly, here, or during the Somme battles. So other features of underground tactics that were new to the miners and mining engineers in particular was listening. And your means of intelligence underground is through listening to the sounds that are made. And specific miners were selected as listeners. You can see the graffiti from Vimy Ridge of 1917, listening duties by a couple of listeners who were working day after day, just sitting in chambers, barely yards from the German tunnels, listening for enemy activity. And this was revolutionized by pieces of technology. The officer crouching in that photograph has actually got a listening device called a geophone. And this is invented by a professor of physics at the Paris Sorbonne University. Quite a simple, comparatively simple device which amplified the underground vibrations so that you could listen to them. And it enabled a skilled listener with the right aptitude to work out both the nature of the sounds, but also the direction. And this would be a crucial way of working out what was going on underground. Had quite a revolutionary effect on British and French mining operations. The Germans had relied more on electrical microphones. And in fact, by placing these in galleries and remotely monitoring them, were able to avoid considerably casualties underground. And my research into the Somme sector at La Boisselle, comparing the British and German casualty rates, has made me realise that in fact the Germans suffered almost no underground casualties as a result of British explosions, because they were using microphones to monitor activity. British cottoned onto this only after the Battle of the Somme and started using their own methods, again using French technology, and these would be monitored at central listening points in underground stations in the mine systems, which is what you can see on the right. So this is technology that was introduced that was unknown to the miners. A little sideline to that is that you have to deceive the enemy in terms of what you're doing, because you know that the other side is going to be listening to you. So if you lay a charge, for example, you're hoping to take the Germans by surprise, but they probably will have heard the activity of you enlarging your mine chamber to take the explosives, of you dragging up the boxes of explosives and backfilling, tamping to keep the explosive force where you want it to go. So both sides would use false noise. They'd use dummy picks, for example. The drawing is of a German dummy pick found on the Somme, spring-loaded pick that was placed at the front, operated with a long rope. And the one on the left is one that we found at La Boisselle, a British attempt at a dummy pick that would be bolted to the mine timber, pulled by a rope, the weighted bar, pivoting bar, used to simulate noise. These weren't very successful because it was too regular in noise, and the tunnel that you were digging never advanced towards the enemy. So after a day or two, you'd realize it was fake noise. More successful was deception underground. And this diagram is showing us how you could use two tunnels, using a shallower tunnel to disguise the advance of the deeper tunnel. If you keep the distances between the German gallery equal, and you'd work out the location of the Germans by listening and taking bearings from your listening galleries. As you advance your two galleries, you'd make sure that the two distances D and D1 are the same. You work noisily at the shallow level, and you would disguise the deep noise from your deep attack gallery, thereby getting your gallery where you want it to be underneath the Germans. And this was certainly used on many occasions, or tunnels trying to use this method. At Hill 60, for example, the Australians deliberately concealed the existence of their deep 100-foot gallery by working noisily at the 50-foot level. And the Germans, if they felt they knew where their opponents were, would actually feel reasonably content. So if they believed, as they did at Hill 60, that their opponents were only at 50 foot below ground, then they were reasonably content about that, because they were oblivious to the fact that they had got beneath them. A feature of underground warfare, which was especially feared by miners, was contact underground. And this was a feature especially of early 1915 mining, before there were good listening devices, as they were working through the sand and clay of Flanders. It's less common to break into an opponent's tunnel in chalk because you're working, it's so difficult to work quietly. But this was certainly a feature of underground warfare. And one of the companies, at least, used a cut-down rifle that you can see the drawing of. Others equipped their men with daggers in case of contact underground. And where contact occurred, usually both sides would avoid actually meeting anyone underground, but there are several instances of both sides, in fact, stealing each other's mine charges, breaking into a gallery, not meeting any of the enemy, but finding the detonator leads, following leads along the gallery, finding mine charges, and both sides removed those charges after obviously cutting the leads. The drawing at the bottom is rather disputed. A Canadian mining officer named Westacott in the 1950s left detailed descriptions of a long battle that he said occurred a place called Mont Sorel in the Ypres salient between the Germans. He said went on for several days. The curious thing about this is that it's impossible to verify from any other source. And quite recently, a Canadian historian decided that Westacott had simply made the whole thing up. I think the sort of jury is still out on that, but that was the drawing that Westacott drew of this combat underground that he described. But it did occur. combat underground did occur, but it was something that both sides really sought to avoid, and they would solve the problem simply with explosive charges rather than actually meeting the Germans face to face. So I turn now to the last part of the talk, military effectiveness. Was it worth the effort? So at the time, it was really regarded as just being a huge nuisance. One British general, Ivor Maxey, he took over this front that's illustrated at Fricourt, and he lamented the fact that thousands of men were being drawn into this labour, which he said was useless but inevitable. And you can see the contrast between the sector before mining and after mining, between May 1915 and June 1916, where no man's land just becomes this mass of mine craters. And all this activity is just to keep the status quo, just to stop the one side or other from capturing the frontline trench. I think the problem faced by commanders was that if they didn't counter enemy mining, their own fronts would collapse and they would have to pull back to a new line. Now that's a quick and easy way of foiling a mining attack, but then you'll have to do it in a few months' time again. If you don't counter enemy mining, that'll just keep happening, and it would have meant ultimately the collapse of say the British defensive fronts if they hadn't engaged the Germans underground with mining. So both sides hated mining, and both sides were well aware of the waste of manpower that it entailed, but saw no choice but to engage in it. And the trick was really to turn it to your advantage and to find a way of harnessing it for the offensive. By the end of 1915, the British and the French and the Germans had lost interest in using mines as an adjunct to an attack. And you had this situation, say here in the Argonne front, where the geology was very suitable for mining. There's a kind of soft limestone called gaze, and the Butte de Wallencourt, spectacular place worth visiting on a day when you can get into the tunnels, because both sides just burrowed out this hill. And today you can see that in fact there's not much of the hill left because of the mining activity, because of so many underground explosions. And the profile that you can see shows German galleries on the left, French on the right. By 1917, you have stalemate, you have the galleries touching. They were actually, the miners were able to shout at each other through the walls of the mine gallery. Christmas 1917, there was a sort of a truce where they sang to each other until the Germans blew a charge. And then you can see that gallery on the left zigzagging down to 94 meters below the summit. And it's inconceivable really that would have been of any benefit really to the Germans. They'd have had to have detonated such a massive charge to have had any impact at all. So the only benefit it would have been as a extreme defensive measure. So I talked about the development of defense in depth. Basically by 1917, certainly by 1918, these sorts of defenses didn't fit in with the German method of flexible defense in depth, whereby they were actually going to lure in their attackers and then destroy them with artillery. And so positions like this, where they're cramming huge numbers of men into underground installations on the front line, just didn't fit in with the German doctrine. And so both sides in 1918, both sides by sort of tacit agreement pulled out, left the microphones in the charges, blocked up the mine entrances with barbed wire, and just stopped doing it. The British persisted with the belief that they could use mines to help the attack. So I showed you the mines at La Boisselle on the Somme. There's an aerial view bottom left of that Lochnagar mine, one of the flanking mines that I said failed to help the attack at all. Also on the Somme, battle. Another mine very skillfully laid beneath German position at Beaumont Hamel, detonated 10 minutes before zero. No one could really explain afterwards why they'd done that. No one would own up, but it gave away the surprise of the mine and the attack. Germans were always better at capturing mine craters that were blown, and they end up in possession of it. These mines do not help the attack at all, so all the effort is wasted. The lessons really of the Somme for mining came both in how to use those mines and detonate them at the right time, but also the Russian saps that I talked about, those shallow tunnels across no man's land, not hugely successful during the Somme, but rethought as a result of the Somme and 4 attacks in April of 1917, reformed, really recast as subways to get troops up to the front line. So if you go to Vimy Ridge today, you can go in a short length of one of these subways, a dozen subways dug to get the attacking troops, Canadian troops, up to the front line. Likewise, in Arras, underground quarries were incorporated into a system of tunnels, sheltering troops ready secretly, safely for the assault. And these were used for the British attack at Arras on the same day as at Vimy Ridge. Finally, in terms of the military use of mining, finally, the British kind of got it right at Messines. We had 19 mines laid beneath the ridge using this method of getting down to the clay level. The Germans were almost entirely unaware of them. They had strong suspicions, but Fürstlein had strong suspicions, but he had no idea that these 19 charges were going to be fired, all blown at 0, 3:10 in the morning, simultaneous to about 2,000 guns opening fire. That, incidentally, was what was heard in Downing Street, or rather was heard in London, heard in Kent by Lloyd George, who was not in Downing Street. Lloyd George, Prime Minister, claimed to have heard these mines going off. He didn't, because these mines just didn't go bang. An explosive charge 100 foot below ground doesn't make a bang that you can hear on the surface. He heard 2,000 guns firing. He was at home in it's Kent or Surrey, where he lived. Wasn't in Downing Street, but he heard the noise of the guns going off, and the assault was successful as a limited objective battle. The mines, it was later claimed, killed 10,000 men. They killed hundreds, not thousands. The Germans were not holding their front line in such strength that there was that many men. The Germans lost 10,000 over the whole course of the battle, over a week. But these 19 mines, 423 tons of explosive in total, were really the swan song, really, of the British offensive mining effort. Some of these mines have been in place for over a year, waiting for the right moment to launch the attack. The ridge was successfully taken with their help. By this time, the British were learning how to assault German positions to the degree that they possibly could have done it without the mines, because the artillery was becoming so effective. But in this case, the mines did help, and the mines did take out key positions that were capable of enfilading no man's land. And you can see that almost every position that is on a spur on the German line has a mine under it. And the only place that doesn't, Petit Douve, was where the mine was lost. The mine was placed, but we lost control of it, sadly. So it's still there, one of 4 or 5 mines that are still under the Messines battlefield. So almost my last slide then is of 2 of those craters. Peckham mine, 39.5 tons, and the Caterpillar crater today. Nearly all of these mines survive today, 32-ton mine. So these are the memorials, really, of the tunnellers, the miners, and the mining engineers who brought their skill to bear. So thank you for bearing with me. I've probably gone on for a little bit too long. I think that's my last slide. So there I am beneath the La Boisselle tunnels. So can I pass you back to Tony? Shall I go to the camera now? Okay. Okay, Tony. Do we do questions now? I think when Tony puts his microphone on. Okay, Tony.
Right, can you hear me now? Sorry.
I can hear you now, yes.
Sorry about that.
Okay.
Thumbs. If you click onto the Q&A tab, there's quite a large number of questions. I'm not sure how much time we've actually got, so I'll let you kick off.
Okay, now I just have to get that tab.
Simon, we've lost your audio.
Okay.
Hang on. Okay, I got it back.
Okay, now I'm just looking for my Q&A tab. Chat. Is it on?
To the right at Q&A.
Okay, Q&A. Okay, here we are. Right. So I'm maybe going to take some questions as I can see them. Jacob from the USA. At what level was mining incorporated into planning? Were offensive actions planned around the use of mining? Was the case of coming up with an offensive plan and then asking what mining could do to support? Okay, yes, good question. So I haven't really focused on the military side of it so much for this talk because I was talking about technology. So this whole point about the command and control of mining at the end of 1915, the British moved the control of mining up to the army level, and this was really important. They took it away from divisional commanders, and it was at army level that these operations are going to be planned. So you have key battles in 1916 where mining is using a Saint Aloy attack in March that Plumer's Second Army plan, and of course the Somme that is Rawlinson's Fourth Army that is planned at that level, and Messines again, it's Plumer's Second Army. So it's very much the army level that this is moved up to, and that is crucial for the operational control of mining and the British use of mining. And Fusslein, the German mining commander for the German Fourth Army, is complaining that divisional commanders are just interfering in what he's doing. And the tunnellers themselves, the British officer, senior mining officer, Napier Harvey, Brigadier Harvey, who was at GHQ, says that this was crucial, that they had to take mining away from the brigade commanders and the divisional commanders and move it right up to the army level. Okay, so Robin Sanderson, couldn't Germans work out a dummy gallery? Also surveying the direction, as did the Australians, effectively, i.e. not just distance sound level. Yes, surveying the direction. So when you have more than one listening gallery, you're using your geophone, listening with two geophones, one in each ear, to work out the direction of that sound. And then from the end of the gallery, you would take a bearing. And then if you've got two galleries, you've got two bearings and you intersect them. So they are doing exactly that. And the problem with a dummy gallery, as I think you've identified there, Robin, is that the gallery isn't advancing. And so if you're taking a bearing from that noise and then you take another bearing from that noise 2 days later, if they're exactly the same, then you realize that it's not a real gallery. It's not moving forward. Okay, so moving up, I have a question from Phil. Did the geology and or technology favor the Allies? I think in general it didn't favor either side, except maybe specifically on the Messines front, where the Germans afterwards said that it was much more favourable to the British because they were closer to the clay level. Interestingly, there's a geological profile that appeared in the German official history, which exaggerates this to the point of almost being deceptive. It did favour the British a little, but ultimately it was the skill of the British mining engineers that was the biggest benefit. Now, question about how much modern high explosive will be needed for a similar amount of explosive power. I can't answer that, Roger. I'm afraid I'm not an explosive expert. The aminal is what you might call a medium explosive rather than a high explosive. So it's not as powerful as modern explosives, but the aim wasn't power, it's more lifting ability. So you don't want it to be a really fast detonating explosive. You want a little bit of delay for the power. Let's see what else we've got here. I see something from Chris. Could you say something about the technology of a navigation digging forward over such distances and the detection of the enemy's mining? So yes, so the sort of navigation, how do they know where they were meant to be? One of the problems for, if you like, the field engineers, the military engineers, is that they weren't trained in mine surveying. And so when the British took over French mine workings, they would find that they're really badly plotted, that the plans didn't match what they found underground, and that they were going in the wrong direction, because your average military engineer officer hasn't been trained in mine survey, whereas the mining engineers had. And often the first job that they did, or always the first job that they did on taking over mine systems, was to properly plot them. And they had the skills and the equipment, miners' dials, a kind of theodolite, underground theodolite, that they would use to properly plot them, so that they could know exactly where they were underground without reference to the reference to the surface. They could dig tunnels from opposite directions under no man's land, and they would meet almost exactly, in that kind of channel tunnel scenario. So they had the skills to do that. Detection of the enemy's mining, yes, I mean, using those listening devices and the method of taking a bearing that I mentioned. Now, Gary Davis, is this all in your book? Yes, it is. Yes, it is. See if I can just move it up. There's a question, yes, why did third Australian spades have slots easier to push in, or for the chalk in the loose Hullock area? So the slots in the spade supposedly were maybe to make them lighter, or to maybe so that the clay didn't stick to them. That drawing that I showed of the clay kicking grafting tools, that was recorded at a clay kicking contest that was held in the Second Army amongst all the different tunnelling companies to see who was the best at clay kicking. And they noted the different designs of the spades, and it was noted that the holes weakened it to the point that when they were really going at it, they were actually bending, and the spades weren't strong enough. I think it was it's partly for lightness, but it was also to stop the clay sticking to it. Okay. Question from Mike Williams. I've heard the strategy of the Lochnagar mine was to raise a crater to provide cover from machine gun positions. Yes, they never explicitly say this. This is one of the frustrating things, especially about the Battle of the Somme. They didn't record the intention of what they're doing. You simply know what they're doing. So these two big mines that were placed at the flanks, the flank of the village, were overcharged. They had far more explosive than was needed just to make a crater. And the effects of that was to throw up high lips. And that is almost certainly deliberate. Partly the high lips would have the effect of burying German positions, but also the high lips would have two tactical purposes. Firstly, they can shield German observation from the village across the valleys on either side. So the Lochnagar crater lips would shield German observation from the village of Lochnagar across to Sausage Valley beyond. And likewise, the Weissap crater lips could shield observation across Mash Valley. And the other value of the lips potentially is once you capture them, then you've got a more valuable field of fire to defend the crater. So yes, the lips have a tactical position, a tactical purpose, and one of them does definitely seem to have been to mask German fire from the village. Jacob is asking, are there examples of mining used in the Italian theatre or in less static fronts elsewhere in the world? If so, how did it differ from the Western Front? Certainly a huge amount of mining on the Italian fronts. And I suppose the main difference is that it's being carried out through rock. And so you need to use mechanized drilling to get through it. But in other respects, it's very much similar. Mining was used a lot at Gallipoli as well, and typical of the kind of 1915 mining, so shallower, smaller charges, but it was used a lot. And there's also very interesting work at Gallipoli in terms of the sort of tactical use of tunnels in the attack, which is partly built on the Western Front. Incidentally, not particularly successful in the attempts to use tunnels in the attack, although it was a part of the Lone Pine fighting, for example. Right. Are we okay for a couple more questions, Tony?
Yes, it hasn't cut us off yet, so keep going.
Okay, we'll keep going. Right, question from Peter. I believe that Russian saps were not used as intended at the Somme. Why was this? Overconfidence in the barrage, lack of comms between engineers and infantry. Okay, so you might remember I showed you the plan early on of Russian saps going across no man's land at Beaumont Hamel. And Russian saps were prepared for the opening of the battle, the 1st of July, but also subsequent attacks in September, and also in particular the 13th of November 1916 attacks. And there was misapprehension about these Russian saps, in that there was a belief that arose to some extent after the war that the intention of the Russian saps was to somehow feed the attacking soldiers through the tunnels and avoid the need for them to cross no man's land in the open. And that was never their intention. That was never going to be feasible. There were some attempts to use the tunnels like that at Gallipoli that ended disastrously, because a small number of men only can leave a tunnel at any one time. This tunnel that potentially would open up in no man's land, potentially in full view of the enemy, and they just become very easy targets if there was going to be any attempt made to use the tunnel in that way. So there was no intention of using these Russian saps on the Somme to somehow solve the problem of men crossing the open ground of no man's land. The way that the tunnels were going to be used was to deal with the problem of holding a German position immediately after the point of capture, when it would inevitably be counterattacked. And at that point, you need to get supplies through, and you need communications back. So the Russian saps were going to be used to have telephone wires through, and they were going to be used for the runners to take messages back, and they were going to be used for resupply for ammunition and water to go up to the capture positions. And that was always the plan for them. They were also used as advanced positions for machine guns and mortars as well, with some success. So on the 1st of July 1916, very few of the Russian saps were used. In the south, they weren't used because they weren't needed, because the German front line was taken, as were the successive lines. So southern part of the Somme, where it was successful, there was no need for them. In the northern part, at Serre, they couldn't use them because they hadn't even got into the German front line. so they were of no use. And in 2 other places, they were of crucial value. So at La Boisselle, near to the Lotnagar mine, where there was a footing in the front line, and equally at Leipzig Redoubt, where again, the British had a footing into the German front line. They were vital for keeping up that communication with the tenuous hold, to maintain the tenuous hold. And they were used extensively to get ammunition supplies up to the line, as well as to be a means of communication as they were intended. As the battle developed, and subsequently it was realized that the most valuable way to use tunnels in the attack was in effect as subways, and this is what they came to be called. So the Vimy tunnels, the 12 subways that were dug, were never intended to cross no man's land. They were used instead to cross Soire Valley behind the British lines, to get the troops up into the front line, to mass them safely and secretly without the Germans realizing, and as a place to have the very large numbers of troops that you need for the assault ready, hidden, to take part in the attack. Exactly as the Germans had used Stollen prior to the Verdun attack in February of 1916, actually, to conceal the assaulting troops. And tunnels are also used for headquarters and for mortar positions and that sort of thing for the Battle of Vimy Ridge and Arras. So that's how they develop. So there is this misnomer, this misunderstanding, perhaps, that somehow a big chance was thrown away with the Russian saps. Okay.
Couple more, and I think.
Okay. Question from Roger about my tunneling tour. Can you contact me privately about the tour, and I'll answer your questions there, Roger, if you can. Let's see if I can get to. Were some nations better prepared than others to conduct military mining? I think that certainly the Germans were better equipped. The French were better equipped. The British were least well equipped, and I think because we were so badly equipped, as with our armies as a whole, we had to really wholesale just adopt the civilian approach, and that was ultimately a benefit, I think. So the British were least well equipped, and ultimately, in some ways, became the best at it. And the question from Philip, yes, it's a similar point. See if I can just get up for one more. Okay, maybe the last one then. What sort of numbers of additional labour infantry pioneers were used around the mining areas? From Richard. So this is an important point to make, because for every one man that you have mining, for every skilled miner that you have, you'll maybe need 3 men to carry away the spoil. So of those, 25,000 men, maybe only a quarter of them might be the skilled miners. The rest will be removing the spoil, and this was a huge drain of manpower. And this is one of the reasons why it was disliked so much. You just need so many men, and the tunneling companies, they realized that the only solution to having enough men was to permanently attach them. So a company strength might be 250, 300 men in Royal Engineers. Potentially these tunneling companies could be 900 strong with attached labor. So rather than rely on working parties being supplied, they'd actually have their own infantry attached to them. So large numbers of infantrymen were attached for periods of months to tunneling companies just to provide the labor. So not a particularly pleasant job for the infantry, but much of a muchness maybe compared to trench warfare. Okay, maybe one last question, Tony, do you think? Yep. Actually, there's a question that I can't answer. So, from Hillary saying, mining, of course, can mean mineral extraction. Is there an example of military miners stumbling on valuable minerals which were afterwards exploited in peacetime? I don't know of one, actually, certainly not on the Western Front. They were just mining really through, the Flanders sand and clay, or the chalk of Somme and Artois. Occasionally they found interesting artifacts. There's one of the tunneling companies found parts of a mammoth, which they had in their dugout, which unfortunately they lost when the Germans attacked. But I don't think they found any valuable minerals. The geology of the areas that they're mining in simply didn't correspond to that. And also they're not going as deep. They're going to maximum maybe 200-foot depth, usually 100 foot. So they're really maybe not going deep enough to find minerals. Okay, Tony, do you think we should wrap it up there?
Thank you, Simon. That was wonderful. Everybody seems to have enjoyed it. Wish you a happy holiday and healthy new year, and to all our members, happy holiday, healthy new year. And it's time to pay your subs, may I remind you. And also, buy Simon's book.
Oh, yes,
all right.
Yes, buy the book. Okay, thank you all. Thank you all for listening. Thanks for bearing with me. Thank you. Bye-bye.
Thank you very much on behalf of Subterranean Britannica and its members.
Okay, thank you. My pleasure.
Cheers.